You're looking at the Titan supercomputer, which is perhaps the best computer anybody could have for playing video games or for doing any type of scientific, computational, quantitative analysis, number data crunching. This is a seriously huge, big, gigantic computer. It's one of the supercomputers that's out there in the world, and I think it's kind of beautiful how they didn't just make it a supercomputer farm like these guys here, right? Like, okay, supercomputer, 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 all black, supercomputer, right? But with the Titan, they gave it some style. They put some color on it. They made it look beautiful. And, you know, here's a website introducing Titan, advancing the era of accelerated computing. And if you go to Wikipedia, you can read about the Titan supercomputer, and it tells you that it's a supercomputer built by Cray at Oak Ridge National Laboratory, which is located in Oak Ridge, Tennessee. Oak Ridge, Tennessee came online in November 2012, and it's ranked first on the top 500 list of the world's fastest supercomputers as of November of 2012. Fastest supercomputer in the world in Oak Ridge, Tennessee, the Titan. The Titan, the Titan, and it looks beautiful. And if you want one for your house, you better have bagazillions of dollars because it's got to be super expensive. And the other thing which is interesting to notice about it is that it is a Cray machine, Cray. And this guy Cray right here is, you know, originally is a guy named Cray. I think his name was Alan Cray. Cray Research, Cray. Background, let me just search, find Alan Cray, no Alan Cray, I don't remember the guy's first name, but it's a guy who created supercomputers, and his company is still going, and Seymour Cray, there we go, and yeah, so Cray supercomputers are computers that are out there, and it's kind of good just to know that, you know, supercomputers, Cray is one of the manufacturers, if not the main manufacturer of them. I haven't ever heard of any other manufacturer of supercomputers other than Cray, but I'm sure they exist. So you might ask yourself, what is a beautiful, badass, massively huge computer like this? Well, what kind of operating system does it run? Because when we talk about operating systems, we know we got the hardware right here, and then on top of that's the operating system. So, you know, are they running Windows? Are they running Windows on this? I doubt it. I doubt they're running Windows. As a matter of fact, I know they're not running Windows. So when we talk about different types of operating systems, one of the ways we could categorize operating systems is by size. What kind of a computer is the operating system running on? How big is the computer? So just like we categorize computers by size when kind of looking at, you know, different ways we could categorize computers originally. And these are the different size categorizations for computers. And also, interestingly, or no coincidence, that each of these sizes of computers has an operating system written specifically for it. Because as you kind of go up in size, you start to get different hardware demands, right? You start to have different hardware demands as you go up in size, or different hardware configurations as you go up in size, or different functionality that you want your hardware doing. And so different operating systems are written for the different hardware that's out there. And since we categorize hardware by size, one of the ways we could categorize operating systems is by what kind of a computer is it written for. So we have operating systems written for supercomputers. And when we look at operating systems, I really like this thing in Wikipedia here where they sort of break out examples of operating systems right there. And we have Unix and Unix-like operating systems. And those would include Berkeley software development and its descendants, which is a type of operating system that's out there. And a lot of other operating systems are built off of it. It also includes OS 10, so Unix and Unix-like operating systems. This is kind of like, you know, oh, my Bible history just kind of went back. Mind blank, whatever, whoever the fathers are, Abraham and somebody else, from which, you know, everybody kind of, you know, went out in different angles. And so Unix is one of the main fathers of operating systems and computers. And so there's a lot of Unix and Unix-like operating systems. So there's like BSD and its descendants. There's OS 10, which is the max. There's Linux, right? And Linux is a bunch of different flavors out there. Red Hat, Debian, Ubuntu, Linux Mint, Google's Android, right, for your mobile phones. See, Windows is its own category. Yeah, so that's just kind of laid out funny down there. Yeah, no distinction down there. Up here, at least they have one. All right, so the Unix operating system, supercomputers, probably going to be running more of like a Unix operating system or something like that, written specifically for it. Let's step back and actually look at embedded and mobile operating systems. So embedded operating systems would be operating systems that are built right into devices, And traditionally, these were operating systems that couldn't be changed. They were often built right into the hardware, sort of like BIOS is built right into ROM. And back in the day, you couldn't update BIOS. It was just physically built into the hardware. And it was actually called firmware because it was a combination of hardware and software. So between hard and soft is firm. And since it was a combination of software and hardware, they called it firmware. And back in the day, embedded systems cannot be changed, cannot be updated. They're built right into the hardware. And so that would be like, today we think about embedded systems like, just like today, BIOS can be updated, right, with flash memory and things like, that, and settings that, are powered by low batteries. Just like operating systems can be updated today, often embedded operating systems can probably be updated today. So that'd be like cash registers, digital photo frames, GPS devices, ATM machines, medical devices, robots. That's how one textbook categorized it. It's just a device where an operating system's built into it. Like I would think of my watch, right? Like my watch. These aren't necessarily the best examples here. Let me get rid of them. I'm going to put my watch. That's the best example. My wristwatch, which is in my truck right now. Otherwise, I'd show it to you. But you know what? My wristwatch, it's got to have its hardware, and it's got to have some sort of operating system to make it run. And that operating system is not going to be updated. It's a cheap Timex watch, $39, right? Timex watch, Amazon. Yeah, see, here we go. Right? Digital, right there. Okay, 21 bucks, right? This is not going to have an operating system that I can update, but it most certainly, definitely does have an operating system built into it. And so that would be an embedded operating system to make that watch work. A mobile operating system would be something that would go into a mobile device, right? So here we have mobile operating systems. You see things like Android, which is kind of like the Google family camp. And we have iOS, which is like the iPhone family camp. And then there's a whole bunch of other ones here. But look at all the different operating systems that are there, right, for mobile operating system. Windows Phone, excuse me, BlackBerry. Again, feeling like I might vomit, sorry. Just kidding. And then we have desktop operating systems. And when we refer to desktop computers, that category includes like desktop computers like I'm using. It includes laptops. Sometimes you'll hear people say PCs. And PCs generally refer to things that are running Windows, and then sometimes you'll hear people say Macs, and Macs refer to, Apple computers running Mac OS 10 or something. So all those phrases can be used interchangeably, pretty much. So desktop computers, if you look for desktop operating systems, and we'll go over the types in a different video, but yeah, it basically, if you go to Google and say desktop operating system, it takes you to Wikipedia, at least it takes me there. For operating systems, which is the main thing we've been looking at. And so that's just another category for OSs by size. You'll find the Windows, you'll find the Unix, Linux, Mac, OS 10, that kind of stuff. Then we have server operating systems. And servers are computers that, connect other computers, and they help, they serve them, kind of like servers in a restaurant serve customers and clients who come into the restaurant. Server computers are connected to a bunch of clients, and they fulfill requests. They fulfill requests just like a server in a restaurant. So there are server operating systems, and there's obviously different demands for an operating system that is fulfilling requests for a bunch of other client computers. And so we've got server operating system software. We've got server operating systems, and you can see some of them here. There's like the Linux flavor. That little penguin is a Linux Fellow, that's the icon for Linux, as is this Red Hat's an icon for Linux, as is Ubuntu right there, as Linux. We've got Windows servers, and here's Mac OS 10 server, right? And just by kind of looking at these images, you get an idea of market share pretty much. A lot of Windows, a lot of Linux, a little bit of Mac. All right, and then finally we have a mainframe operating system. So mainframe computers. You know, if you search Google for mainframe operating system, Wiki, you just get history of IBM, a ZOS, right? Which again produced by IBM, IBM mainframe operating systems, IBM, and generally these are going to be Unix-based operating systems, from what I know of them. You know, and IBM is one of, if not the main kind of thing that comes up when you look for mainframe computers. So what is a mainframe computer? Let's just look at one, mainframe. And here's some images for mainframe. So they start to look sort of like, you know, bordering on super, but they're not super, right? So compare like that image or this image, you know, a little bit smaller than like the Titan. Not going to be quite as awesome or as badass as the Titan. So these would be used for running like Shell Oil Company or Disney or, you know, pick your favorite multinational corporation. All right, and then of course we have supercomputer operating systems. You know, while early operating systems were custom tailored for each supercomputer, the trend has been to move away from in-house operating systems to the adoption of generic software such as Linux. How awesome is that, right? So this guy created an operating system and now it's being run on supercomputers. All right, so those are some of the categories for different types of operating systems, categorizing them by size. And if you look at operating systems on Wikipedia, and you look at the types of operating systems, the categories they use, you know, it just kind of, one, shows you how arbitrary it is. Like when I was in school, is sometimes for me, you know, there was this idea that there were all these answers out there and they were the right answers. And as I've gotten older, I realized adults just really don't know what the hell they're doing and they're just making it all up anyhow. They're making it all up also. Adults are just making it all up also. And sometimes it makes sense and often it's all also very arbitrary. And so when we talk about categories of operating systems, hey, hell, whatever, why not? We could categorize them by size, which I just did. And if you go over to Wikipedia, they don't even categorize them by size, right? They categorize them by if it's a real-time operating system, which means that it responds to events and it's happening in real time. It's just like, you know, event-driven, right? And then is it a multi-user operating system? Does it allow multiple users to access a computer at the same time? Does it do multitasking versus single tasking, right? And this is really sort of an older deal, single tasking. So multitasking just means you could run more than one program at the same time. Is it distributed operating system, which I think is kind of cool, which is it manages a group of independent computers and makes them appear to be a single computer. That'd be a cool one. And then they just have one here for embedded, right? So if it's embedded, but that's one category that I picked up. So those are the ones from Wikipedia: real-time, multi-user, distributed. Those are different types of operating systems. The most common way I think about types of operating system, right, is like, okay, what kind of a system does it go on? Does it go on a really big system like a supercomputer, which would be running like Linux, apparently? And the biggest supercomputer in the world is beautiful Titan, the beautiful Titan, the fastest one in November of 2012. So is it a mainframe operating system? And those just generally seem to be made by IBM. That's what I've always heard when it comes to mainframe operating systems, IBM. IBM, actually, let's go look at that real quickly because there is, where did we go? Mainframe. We got to go back and mainframe and go back. One more, history of mainframe operating systems. And what do we got? Fortran. Oh yeah, Fortran. So Fortran is like something you hear about if you get into computers. You hear people sometimes talk about Fortran. Like, you know, it's, you know, old school, how they used to program things. Anyhow, so mainframes, and then there's server operating systems, right? And Windows, Apple, Mac server, Windows server, Linux also has server software. And then there are desktop operating systems, Windows, Mac. And then there's mobile operating systems, you know, like iOS and Android. And then there's embedded operating systems, like for my wristwatch. How's that running? It's hardware. It's got to have a little operating system in there. It's an embedded operating system. So there we go. So there's some categories for understanding operating systems. And that's the way I often think about them right here, which is why I gave you this categorization.